Hi everyone, my name is Lai Xinrou from Group 3 and my group member are Li Xingyi and Xiao Huiyan. Today we would like to present the properties of normal distribution graph. The properties of normal distribution graph. When the sample size n become large, we cannot estimate the values from the binomial table. So we can use the normal distribution to determine the answer which has a large sample size n. Below are the conditions needed to determine whether the size n is large enough or not. When mean is greater or equal to 10, well, p is the probability of success, and 1 minus p, which is q, is the probability of failure. So what is normal distribution? A normal distribution is a probability function of a continuous random variable, and the distribution is symmetrical with most of the data clustered around the center close to the mean. The probability for the data further from the mean taper off equally in both directions, which is 50% of the data values is less than the mean and 50% of the data values is greater than the mean. The diagram shows the normal distribution function graph.
Important features of a normal distribution function graph. The first one is the curve is bell-shaped and is symmetrical about a vertical line that passes through the mean. And then the curve has a maximum value at the axis of symmetry, which is equal to mean. And the mean divides the region under the graph into two equal parts. Both ends of the curve extend indefinitely without touching the x-axis. So the total area under the graph is equal to the probability of all outcomes, that is 1 unit squared. In general, the notation used for a continuous random variable x, which has a normal distribution that can be written like this. The shape and position of normal graphs. The first graph is the shape of the graph do not change, and the axis of symmetry at the mean moves according to mean value when the standard deviation is kept constant. So the conclusion is the larger the mean value, the more to the right the position of the graph. Okay, let's see the second graph. The second graph of the standard deviation affects the height and the width of a graph, but the position does not change. So, the larger the standard deviation value, the larger the dispersion of the normal distribution from the mean value, and the height of the graph increases when the standard deviation value decreases if mean is kept constant.
Look at the normal distribution graph below. The area under the graph for x from A to B represents the probability of x occurring for the value of x from A to B, and is written as this. These two are same. This is because the normal distribution function is a continuous function. So now let us do some exercise. The diagram on the right shows a normal distribution function graph which is symmetrical at x is equal to 35. Question A. Set the mean value. From the previous slide, we know that the symmetrical at x is also the mean value. So mean value is equal to 35. Extract the shader region in probability notation. From the previous slide, we know that the probability can be written as this. So probability A, which is 28, and B, which is 42. Then we replace the unknown on this equation. Question C. If the probability of a shader region is 0.64, find the probability x smaller than 28. Since the graph is symmetrical at x is 35 and f is equal to 28 and f is equal to 42, are both 7 units respectively to the left and right of the mean, then probability x smaller than 28 is also the probability of x greater than 42. So we can use the total area under graph, which is 1 to minus the probability 0.64 and divide by 2. So we can get the answer 0.18. Question 2. A continuous random variable at n is 2.3 and 0.16. Take the mean and the standard deviation for this distribution. So from the given information, we can conclude that the mean is equal to 2.3 and the standard deviation is square root of 0.16, which can get 0.4. So thank you.